Hello. In this video we're going to be taking some of the functions we talked about last time and we're going to be translating them, that is sliding them up, down, left, and right on our coordinate plane. So I have a quadratic function here. Notice it's the quantity x minus 3 quantity squared, so I do indeed have an x squared in there if I were to multiply that out. But take a look at this. I have this minus 3 here and this 1 here. The vertex for this is 3 comma 1. Now if I were to adjust this, let's say minus 2, and we'll go plus 4. And there we are, minus 2 plus 4. And so if we know how a quadratic grows, it makes it pretty easy to sketch a function like this. We go to 2 comma 4, and then we just build our parabola from there. Alright, let me set this back to minus 3 plus 1, and I'm going to open up the absolute value one. Now remember, the absolute value function should make a V shape, and there it is. And notice it has the same vertex as a quadratic at positive 3 comma 1. So we have the absolute value of x minus 3, that's where the plus 3 comes from, and then we bump it up by 1 by adding 1 at the end. And again, I can do the same thing. If I were to make this a negative 2 and change this to a 4, it goes back up to the same place that it was up here. Okay, so again, if we know what an absolute value looks like, I can read or interpret the equation, go to 3 comma 1, and build my v from there to get a rough sketch of the graph. Square root. Where do you think we're going to start? It's that sideways half parabola. If I turn it on, lo and behold, we start at 3 comma 1. Okay, and since we know it's a sideways half parabola, I just start at 3 comma 1, and there's my sketch, build up from there. Now a trigonometric function is a little unique. We have to know things about what a sine function looks like. And so there's this here, what it looks like when we have that minus 3 inside the parentheses and the plus 1 outside. The plus 1, if you notice, all it did was make this thing go up by 1. Okay, so originally we are at, let's see, it looks, no, I'll get rid of the minus 3 too. So we're at 0, 0. When I throw that plus 1 in, we are now at 0, 1. If I throw a plus 4 in, we're now at 0, 4. So all this number does is make us go up or down. If I were to change this to a minus, there's our down, into minus 1. Didn't mean to zoom in that far. Let's undo. There we go. So plus 1. Let's throw that minus 3 back in. We were at 0 comma 1, and this minus 3 made that go over here to 3 comma 1. Okay, if I were to change this to a plus 3, now instead we have a, if I can find it, negative 3, 1 right there. Okay, so this is the left, right. Same thing with all of these. You have to know the basic function, what it looks like, the parent graph, but if it's inside the quantity, inside the square root, inside the absolute value, inside the parentheses, that number does the opposite. And so since it's minus 3, it moves right 3. If it was a plus, it would move left. This number at the end makes our functions move up or down. Okay, so we need to know what the parent functions look like, and then we're able to draw sketches just based on